What if it journeyed now, towards our fragile world, a messenger of doom, invisible, silent, deadly, traveling through the void, unseen by any eye, undetected by our science? Would we even know, until the very end? This thought haunts the starlit dark. The universe is vast, impossibly beautifully large. Yet it is not always kind, its wonders can hide terrors. Phenomena beyond our grasp. Forces of unimaginable power. Earth is but a dust mote, floating in an endless ocean, vulnerable to cosmic tides, and the storms they bring. The scariest things out there? They are not little green men, nor are they mythical beasts. They are the laws of physics, operating on grand scales, creating wonders, yes, but also cosmic horrors, objects and places so extreme, they defy easy comprehension and challenge our place here. Imagine a star that dies but refuses to fade quietly, instead it becomes something else. A remnant, dense and twisted, a zombie star, fiercely active. Its influence, vast and terrifying. This is no science fiction, this is a reality of our cosmos, one of many such truths, waiting in the deep. Meet the magnetar, a name that hints at its power. It is a type of neutron star, the collapsed core of a giant, a star that went supernova, exploding in fiery glory. What remains is small, perhaps only a city wide, but its density is staggering. A teaspoon would weigh billions of tons. How does such a monster form? A star many times our sun's mass reaches the end of its life. Its nuclear fuel is spent. Gravity wins the final battle. The core collapses catastrophically. It shrinks with incredible speed. As it shrinks, it spins faster. Its magnetic field intensifies, becoming unbelievably strong. This magnetic field is its terror, the strongest in the known universe, 1,000 trillion times Earth's, quadrillions of times a fridge magnet. So powerful, it warps atoms. It can erase a credit card, from halfway to the moon. This is not gentle cosmic power. It is raw, untamed force, a true cosmic horror. The danger is very real. Magnetars experience starquakes, their crusts crack and shift, releasing colossal bursts of energy. Gamma rays and X-rays erupt, traveling across the galaxy. If a magnetar were close, say nearby, within a few light years, its flare could strip our atmosphere. Life on Earth would cease. For years, astronomers heard whispers, mysterious signals from deep space called fast radio bursts, or FRBs, intense pulses of radio waves lasting mere milliseconds, yet carrying immense energy. Their origin was a profound puzzle. What could create such blasts? From billions of light years away, the universe was sending riddles, then a breakthrough, in our very own Milky Way, a magnetar known as SGR 1935+2154, stirred from its slumber. In April of 2020 it flared, and with it, a radio burst. Not as powerful as distant FRBs, but unmistakably similar. The first FRB seen from within. The first tied to a known object. This discovery was monumental. It linked magnetars to FRBs. These zombie stars in their death throes could indeed scream across the cosmos, their magnetic fury unleashed, creating these fleeting bright shouts. We had found a source, or at least one kind of source. The universe had spoken, we were learning its language. Yet, the story is not complete. Do all FRBs come from magnetars? Some FRBs repeat, others do not. Are there different mechanisms? The cosmos guards its secrets well. Each answer uncovers new questions. These bursts are cosmic messengers, carrying tales of extreme physics. We continue to listen, to the static of the stars. From dense, energetic monsters we turn to a different horror, the horror of utter emptiness. Imagine a place in the universe so vast, so startlingly barren, it chills you to the core. This place exists. It is called the Boötes Void. Sometimes folks call it the Great Nothing, and honestly, that's a name it truly earns. So, how large is this void? Nearly 330 million light-years across. Our minds can barely grasp that. If our Milky Way galaxy were at its center, we wouldn't have known other galaxies existed until the 1960s. It is an immense ocean of dark, where so little light shines. Astronomers expected some galaxies, maybe around 2,000 within a space this large. They found only about 60 tiny points of light in an expanse that could hold legions. Imagine drifting through it for millions and millions of years, seeing almost nothing. Just the cold, unending dark. Its discovery was a surprise. In 1981, astronomers were mapping the distribution of galaxies. They found this colossal hole, this underdense region of space. It was, and honestly still remains, unsettling. Such emptiness feels unnatural, a profound statement from the cosmos about its own grand structure and the surprises it holds. How do such voids come to be? They are not unnatural freaks, but part of the universe's fabric, the cosmic web. Galaxies cluster along filaments like dewdrops on a spider's web. In between lie the voids, the great darknesses. Gravity sculpts these vast empty spaces. Their origins go back to the very beginning of time. The Boötes Void is special. Its immense size pushes the boundaries of our models. These voids are not just empty. They tell us about the universe, its history, and maybe its fate. Now, let us journey elsewhere, to a place of ethereal beauty and slow, relentless destruction. Consider Palomar 5. It appears as a globular cluster, a spherical swarm of ancient stars orbiting our Milky Way galaxy. But it is not what it once was. It is a ghost of its former self, unraveling before our cosmic eyes. Palomar 5 is being torn apart by the immense gravity of our galaxy. This process creates tidal streams, two vast rivers of stars, stretching for thousands of light-years, flowing away from the cluster like luminous trails of breadcrumbs, showing the path of its demise. A beautiful yet tragic sight, a star cluster bleeding into space. What accelerates this dissolution? Recent studies point to a culprit hiding within Palomar 5 itself. Not just one, but many. A significant population of black holes, perhaps 100 or more. These are not supermassive ones, but stellar mass black holes, each a few times the sun's mass, a hidden swarm of darkness. These black holes interact with each other and with stars in a complex gravitational dance. They can fling stars outwards, violently ejecting them from the cluster's gentle embrace, accelerating its disintegration. Palomar 5 is dissolving, its stars scattered into the halo, a reminder of cosmic impermanence. The universe shows us terrors, magnetars, voids, black holes, enough to make us feel small. But the cosmos is also beautiful, sometimes at the same time. Consider the Eskimo Nebula, striking, a little eerie, like a face peering out from the cosmos. It's a dying star's final beautiful act before fading away, so stay curious, look up, wonder.